Something at the bottom of the Mediterranean Sea is breaking the rules of modern engineering. It is not cracking. It is not eroding. It is not slowly falling apart like everything else we build today. Instead, it is becoming stronger with time. Year after year, century after century, and that alone should make us uncomfortable. Look around your city for a moment. Bridges with warning signs, roads patched again and again. Concrete structures designed with an expiration date. Engineers already expect failure. They plan for repairs. They budget for collapse. This is considered normal. Modern concrete is not built to last forever. It is built to be replaced. But 2,000 years ago, the Romans built concrete that refuses to die. In the late 20th century, underwater surveys near the ancient Roman coastline revealed something unexpected. Massive harbor structures, fully submerged, still standing firm after centuries of exposure to salt water and waves. According to marine researchers who examined these sites, the material showed almost no structural fatigue. The walls were dense. The joints were tight. In some cases, the concrete was stronger than when it was first poured. That discovery raised a dangerous question. How could ancient builders achieve something modern science struggles to reproduce? The Romans did not use the cement we rely on today. Their concrete was made using volcanic ash, lime, and seawater. Simple ingredients, but combined with an understanding of chemistry far ahead of its time. When this mixture came into contact with seawater, it did not weaken. It reacted. Over time, microscopic mineral crystals formed inside the concrete. These crystals grew slowly, filling tiny gaps and locking the structure together from within. Instead of decaying, the concrete healed itself. The longer it stayed underwater, the stronger it became. Modern concrete behaves in the opposite way. Water penetrates it, salt corrodes the steel inside, cracks spread. Failure becomes inevitable. We build seawalls knowing they will collapse. The Romans built theirs to outlive empires. If you're enjoying deep stories like this that challenge everything we think we know about history, make sure you like the video and subscribe to History Discoveries. It helps the channel grow and brings more hidden truths like this to the surface. By the early 2000s, scientists began studying Roman concrete in serious detail. Core samples taken from ancient ports revealed mineral formations that do not naturally appear in modern concrete. Laboratory analysis confirmed that these formations developed slowly, over decades as seawater interacted with volcanic material. In controlled experiments, researchers recreated similar mixtures. When submerged in salt water, the same strengthening process began. The results were real, measurable, repeatable on a small scale, so the question shifted from, is it possible? To something far more unsettling. If we can do this, why aren't we? Attempts were made to push the research further. Proposals were submitted to test Roman-style concrete in real marine environments, piers, breakwaters, coastal defenses. But support never fully arrived. Funding stalled, interest faded. Large construction firms showed little enthusiasm. Officially, the explanation was simple. The process was slow, the materials were region-specific, the method did not align with modern construction timelines. Unofficially, the implications were far bigger. A material that lasts centuries does not generate repeat contracts. It does not require constant repair. It does not fit an industry built around maintenance and replacement. A concrete that heals itself threatens an entire economic model. And Roman concrete is not the only ancient material that seems far ahead of its time. Centuries ago, blades forged in India and the Middle East developed a legendary reputation. Damascus steel weapons were known for their strength, flexibility, and distinctive flowing patterns. They could bend without breaking and cut through materials that modern blades struggled against. When scientists examined authentic samples centuries later, they found something shocking. Inside the steel were microscopic structures similar to carbon nanotubes, structures that modern science only formally identified in recent decades. Despite advanced technology, researchers have never been able to consistently reproduce the internal structure of true Damascus steel. Modern versions imitate the appearance but not the performance. The original method vanished, along with the specific materials and forging knowledge required to make it work. Then came another discovery. In the mid-2010s, marine archaeologists recovered metal ingots from an ancient shipwreck near Sicily. Despite being underwater for over 2,000 years, the metal showed minimal corrosion. Laboratory analysis revealed a complex alloy made from multiple metals sourced across distant regions. Some researchers quietly compared it to descriptions of orichalcum, a material mentioned in ancient texts. Early tests suggested unusual physical properties. Soon after, access to the artifacts became restricted. Public information slowed. Research updates stopped. Once again, the pattern repeated: discovered, studied, then locked away. Roman concrete, Damascus steel, unexplained ancient alloys. These were not accidents. They were the result of careful experimentation, long-term thinking, and a deep understanding of materials. Ancient builders were not guessing. They were engineering for permanence. Modern society builds for speed. The uncomfortable truth is that we may not be less intelligent than our ancestors. We are simply working under different priorities: faster construction, cheaper materials, shorter lifespans, endless rebuilding. As history discoveries continues to explore lost technologies, one question keeps coming back. Did this knowledge disappear naturally? Or was it quietly set aside because it did not serve the modern system? If a bridge could last 500 years, would it ever be built today? If concrete could heal itself, would anyone fund its mass production? If ancient engineers solved problems we still struggle with, what else have we chosen not to remember? If this story made you stop and think, share this video with someone who loves history or science. And let us know in the comments what you believe. Was this knowledge truly lost, or simply ignored? Because the most disturbing possibility is not that the past was more advanced than we imagined. It's that the future could have been stronger, safer, and built to last if we had chosen differently.